During the winter months, the Arctic region is cold and dark, with little to no sunlight or solar heat. Sea ice grows during this time, reaching its largest extent sometime in March. When something disrupts the cold, dry, winter Arctic atmosphere, sea ice can feel the effects, and these effects may linger through the season. At the end of December 2015, an extreme cyclone formed in the North Atlantic and swept into the central Arctic. North Atlantic cyclones, like this one, are low-pressure centered systems of strong swirling winds transporting unseasonal heat and moisture into the Arctic from lower latitudes, disrupting sea ice growth. Scientists use the atmospheric infrared sounder instrument on board NASA's Aqua satellite to study the atmospheric effects of this cyclone on the sea ice surface in the Barents and Kara Seas. They observed above freezing temperatures that were up to 20 degrees warmer than normal in some places. As a result of this cyclone, the concentration of the sea ice in the Barents and Kara Seas decreased by 10%, and the sea ice edge moved northward. The loss in sea ice area during this time was equivalent to the size of Florida. Scientists think excess energy input into the surface might have caused the sea ice to thin significantly, although not enough to cause a complete meltdown yet. After the storm, weather conditions returned to normal, but the sea ice extent remained low throughout the month of January, with large parts of the Barents and Kara Seas unseasonably ice-free. NASA scientists say the effects of this storm on the sea ice could have been a tipping point, leading to the record-low Arctic sea ice maximum observed this past winter. As we approach this winter season, after the second lowest summer sea ice extent on record, NASA scientists wonder if cyclones like this one will have similar or worsened effects on the vulnerable sea ice.